Reagan said for a couple of beers, he'll give me his extra 2 minutes. Can you go full screen on that? Right, welcome. My name's Vic Fursey. I look after sales in North America. I'll do my best to talk fast, although I usually talk long. Point of order, I do have an LCMS applications job in our Billerica, Mass facility. Anybody who wants to talk about that for small molecules, please come and see me afterwards. I'd like to thank Mike and all the guys for allowing us some time here at CPSA. And just want to let you know, Bruker, you may know us in terms of mass spectrometry here, but also we are, the major player in NMR. We have a lot of other analytical techniques such as X-ray, FTIR, Raman, you name it. Just bought the VICO AFM division, so quite a substantial company now with certainly well over $1 billion in sales these days. In mass spectrometry, we deal with MALDI-TOF and TOF-TOF. That means microorganism ID to MALDI imaging to a whole other host of things. We also have FTMS, ion traps, lots and lots of LCMS solutions. Maxis being one of them. And this is really the tool I think that you want to start to look at if you're into this qualitative and quantitative analysis in the same run. So that's the main point of the next few slides. Confident empirical formula determination, and be able to also do the quantitative work on the same platform. Final plug, biologics, very much our forte also. Okay, the Maxis ultra-high resolution TOF, analytical figures of merit you should know. 50,000 resolving power at mass 900, give or take, at full sensitivity. So there are no operating modes where you've got a high-res mode and throw all the ions away. This is full on all the time. We've got ppm mass accuracy for parent and product ions. We've got wide dynamic range. We're easily UPLC compatible. You can write 30 spectra to disk per second, no problem. And we've really got super sensitivity, low, even sub-picogram range with conventional flow LC, and certainly a lot more when you go to the nanoflow setups. Glad to see other people starting to adopt the dual ion funnel stuff. We've been going with this for a couple of years, also licensed in from Dick Smith. Give those guys their due. They've done some great work. And in fact, all of our mass specs are going out with these if they've got an LCMS front end on it that have been developed over the last 2-3 years. It's phenomenal. In terms of the other things of this instrument, it's an ultra-high resolution QTOF. It's got some really unique ion focusing devices in there. And basically, you can make the situation where all of the ions that gets pulsed into the TOF are detected essentially without losses because of the ion focusing. So I think it's important to know that although it's a long flight path instrument, we keep the sensitivity. Okay, here's just a proof statement on some small molecules showing you resolution around the 50K mark, just to give you an idea. And that's on a UPLC type separation, 20 Hz. Same story with the MSMS, and you note here just the mass accuracies. These errors are in ppms on the very right-hand column, so we're at or around ppm levels. Now, let's think of half a dozen small molecules here. Separation less than 30 seconds, 1 second wide LC peaks. We've got basically around a ppm on everything, externally calibrated. On the left-hand panel, you can see we've got plenty of data points in order to quantitate that peak. On the right-hand side, you see that the raw spectrum, the mass spectrum underneath, is high resolution, 40,000+ in this case, exact mass, and the true isotope pattern, which is critical for empirical formula finding. Anybody who says you can do it on mass alone, not true. Okay? The one on the left, 1.5 millidalton high-resolution extracted ion chromatograms, just so you can see. All done with full sensitivity. So there's just a proof statement here, serial dilutions on reserpine, going down to the picogram level, still with super signal to noise here, a couple of hundred to 1. Okay, that formula finding, we use MS and MSMS when we get to big molecules. We use the true isotopic pattern, so you need spectral accuracy. And we use a software tool that we've developed with Pfizer called Smart Formula 3D to give you unambiguous formulae. So you get from maybe dozens of candidates based on mass alone to 1. Finally, quantitation. Tim Ola said yesterday we're all forensic scientists, so no boost per ohm for a change. Instead, a bit of forensic tox. 2 more slides. 4 orders of magnitude dynamic range on the quantitation I'm about to show you. Many of these need 30,000+ resolution to resolve potential isobaric interferences. So you really need high res, and here's the proof, some things where we've purposely mixed them to see what's going on if you're going to quantitate at the MS level, which is what this qual-quant's all about. There's your dynamic range with your 3 nines plus linear dynamic range over 4 orders. Here's a curve to prove it. And here is the final slide, 2 million high res out of urine, being able to get some of these trace level, in this case, forensic tox compounds, no problem. So come see us. We're downstairs. We have the booth. And if you want to talk about that position, I'd be glad to have a chat on the side as well. Thank you.